Hi, today is December 13th, 2024. This video is the first video in a new sequence, Python for Beginners in Data Science. In today's video, we'll talk about how to install Anaconda and how to use Jupyter Notebook to create reproducible reports. Let's start from Google search Anaconda. Just search Anaconda, download, and then click this page. You will be directed here. If you want to register, just go ahead and input your email. If you don't, just skip registration. And then you can download corresponding to your system. You might wonder why we need to install Anaconda installation. So that's because it is a very good comprehensive installation. If you take a look at the packages that comes with Anaconda, you will know why. So for example, after you installed Anaconda, all of these packages will be available for you, like NumPy, Pandas, Jupyter Notebook, and for visualization, we have Matplotlib, Seaborn, Plotly. So I use these very often. And also for machine learning, there are scikit-learn, TensorFlow, Keras, etc. Okay, so I highly recommend you install Anaconda directly instead of installing Python by itself. Okay. Then you have to install these packages one after the other by yourself. It will be kind of a headache. Alright, now the installation is pretty straightforward, so I will skip that part. So after you install Anaconda, you can find it in your start menu and then launch Anaconda. Then you will see this page, okay, this platform for Anaconda Navigator. Okay. And you see a lot of distributions or packages are available for you, including this Jupyter. Okay. So in our tutorial, we will use Jupyter most of the time. So let's launch this. Click this to launch Jupyter. Okay. After we click launch Jupyter, we will be directed to a page like this. So this is sort of like the home page of Jupyter. Because I have been using Jupyter for quite a while, I have a lot of folders and documents available already. If you are a beginner in Jupyter, probably this directory is quite empty. Okay. So now let's create a new Jupyter notebook. Just click Python 3. And then we see a new Jupyter notebook is open for us. Okay. And immediately you can change the title. So by default, the title is untitled. We can say it's Introduction to Jupyter. I rename it. Okay. Then I start. Okay. You see by default, only one cell is available. Okay. And for each cell, there are 3 modes: code, Markdown, or raw. Code obviously is for Python code or some other type of code. Okay. Markdown. What is Markdown? Markdown is sort of like a language. You can use it to include text in your report. So let's start from Markdown because Jupyter is very good at creating presentations or reports, and it's reproducible. So let's start with Markdown. So the first topic is headers. Okay, let's talk about headers first. Headers. There are at least 5 layers of headers available in Markdown. One example. Let's see how they work. Let me change it to Markdown. So the highest level, the first level header is denoted by a pound key, 1 pound key. Okay. Then the second level will be 2 pound keys, etc. If we run this, you will see the differences. So the first level header is the biggest, and then the second level, third level, okay? And you can also collapse them, okay, if they are in the same header, okay? So that's headers, okay? Then the next topic is fonts, okay? So let's briefly talk about fonts available in Jupyter Markdown. So first, bold letters. Okay, so how to create bold letters? You can use 2 asterisk. For example, if you type this, okay, you see this bold. The word bold is bold in bold style. Okay. And then what about Italian? Very simple, you just use 1 asterisk. Let's run it. And by the way, you see if you want to run a cell, just click this arrow. And then next, sometimes you want to include some formulas into your report. For example, you want to include a regression formula into your report. You can do the following. And there are 2 ways to insert formulas. One way is called inline formulas. Okay, how to do that? For example, I would say the regression formula is, so for inline formulas, you wrap the formula in a pair of dollar signs. Okay, so for example, the formula is y equals beta 0 plus beta 1 times x plus epsilon. Okay, so you see, for Greek letters, you need to use this slash special notation. Okay. And then period. Okay. If we run it, you see this formula is embedded in a sentence. And obviously, there is another way, which is a standalone formula. Okay. In this case, you just need to use double dollar signs. Okay. So for example, if we copy the whole sentence and paste it here, and get rid of the period at the end, and add a dollar sign on each side. Okay, so you see what happens. The formula is standalone, and it is also centered. Okay, previously, it is inserted in the sentence, and now it is by itself. And that's it about formulas. And the next topic is insert web page links and images. So first, sometimes we want to insert a web page into our report. For example, suppose I want to promote my YouTube channel data flow. I can do the following. My YouTube channel is, okay, so first I need to wrap the name of my channel in a pair of bracket parentheses, and then add a pair of regular parentheses and insert the path, the URL, in the parentheses. So let me go back to my channel. Okay, so it's here. Okay, so copy the shared link and paste in the parentheses. Then let's run the cell. So you see the website of my YouTube channel is kind of highlighted. If I click it, I'll be directed to my YouTube channel. Okay, very convenient. So this is 4.1. Insert a web page. If we want to embed a local image into our report, local means we have saved or downloaded an image into our local folder in our computer. There are a few ways to do it. The first way is to use Python code. Let's see how to do it. So we first need to import a function from a Python package. So the code is from IPython import display. So display is a function. IPython is a package. So I will import this specific function from this package. So we'll talk about Python packages and how to import them later. But for now, let's just use it. And then we can call the function display.image. Then you need to insert the path or directory where you save your image into this pair of quotes. So suppose I want to insert an image of my dog. So I first need to copy the directory and remember the name of the picture. So I would first copy and paste the directory, and then type the name of the image, and also you should include the extension. So if you're not sure about extension, just right click and check properties. You see it's a JPG file. So extension is .jpg. So I will use JPG. Alright. And then let's run this. Oh, it doesn't work. You know why? Because we need to change the slash, change the direction of the slash, and then it should work. Okay, run it. Okay, so the image is included in the file. Another way, which is pretty simple, is to drag and drop the image to the Markdown file. So let me just copy and paste the title here. So drag and drop. How to do it? So first, create a new cell. Okay, so by default, it's code. Don't forget about it. Okay, change it to Markdown first. Okay, so that's why it's called drag and drop image to Markdown cell. Okay, it has to be a Markdown first. Okay, and then locate your picture or image and drag it to the cell. Okay, then you're done. You see, and then if you run it, you see the image is included. This is pretty convenient to insert a local image to your Jupyter notebook. And then what if we want to insert an image from an online resource? We can do the following. Actually, the syntax is the same with this one. We will still use the display.image function. The only difference is that instead of using this local directory, we will include the URL of the image here. So for example, suppose I want to insert an image of Elon Musk into my report. Okay, I can do the following. So first, let me just go to Google, and then I will search for Elon Musk. Okay, and then click images. Choose a good picture. I think this one is pretty good. And then click it and right click the image and click copy image link. Then go back to our Jupyter notebook. Because it's quite long, we can save it as a Python object. So make sure to put the URL in a pair of quotes. Then we can just call the display.image function and just directly put URL here. And when you're done, okay, so see the image is inserted successfully. Just make sure that you have the copyright of the image if you want to publish your work. Otherwise, you may have trouble. But anyway, it is very convenient to insert an image from URL. And lastly, we will see how to include Python code. So very straightforward. For example, if you want to print a sentence, okay, make sure you put the sentence in a pair of quotes. Okay, so for example, let's print hello, new world. Okay, and then just click run, and it works, right? Code and output are all included. Okay, we can also define a variable. Suppose we want to define two variables and calculate the quotient of them. And we want to add some comments. Okay, we can have standalone comments. Okay, for example, define two variables. Okay, we can say x is equal to 200 and y is equal to 5. And then we add another line of comment. Calculate the quotient of x and y. So just directly calculate x divided by y, and then you get the result. Alright, Then let's briefly talk about these buttons and the drop-down menu. So first, this one is save. So make sure you save your Jupyter Notebook before you close it. Okay, Jupyter Notebook does not automatically save your input. Okay, so click save. And this button is used to insert a cell below your current cell. So you see the cell that is highlighted is the current cell. If I click plus, then a new cell will be added below the previously current cell. And this one is cut. If you want to delete the current cell, just click it. Okay. Alternatively, you can click this trash can button to remove a cell. And this is copy. Okay. Suppose so this cell is our current cell. If we copy, we'll copy this cell. Okay. And then this is paste. So click it, then the same cell will be pasted below the previous cell. And it's redundant, let's remove it. And also, this is run and this is interrupt. So sometimes you might have a bug in your code. For example, a cell runs forever, it never stops. It takes an abnormally long time to run a cell. In that case, something must be wrong. Probably there is a dead cycle in your code. In that case, you want to click this button and stop the process, so that you can restart. You can debug and restart. So notice that there is another mode, which is raw. So this one is somehow in between code and Markdown. It will just present as is, no matter what the input is. For example, now it is a code cell, right? If we change it to raw, then it is somehow like a plain presentation of the cell. Okay? There's no output because it's not code. And it's not text either. Okay, so for example, this one, if I click raw, then it will not be a header anymore. So it's somehow useful because sometimes you want to include some code, but you just want to show the code itself without running the code. In that case, you can use this mode, raw mode. Okay, let's change them back. All right, now let's take a look at the file drop menu. There are some. You can create a new Jupyter notebook. You can save the notebook, and you can download it and edit. So the very first function is pretty useful, undo. I suppose you do something that is not good, you can undo the last action, cancel it. And there are some other functions. Okay, and view. I think one function that is pretty useful is this table of contents. If you click this, you will see an outline of the structure of your report is shown here, which is pretty convenient so that you can see the big picture of your report and you can adjust it if you want. And run, you can choose to run a selected cell, or you can run up above selected cell or up below selected cell, etc. A lot of options, okay, which are very convenient to use. And then kernel. So if something wrong with your code, you want to restart your kernel or you want to do something else, these are all available, and some other things. Okay. Alright, I think that's all for this short introduction to Jupyter Notebook. Next time, we will talk about Python basics, basic syntax for Python coding. And see you next time. Today is December 15, 2024. Today, we'll talk about basic syntax, variables, and operators in Python. So it's part of our first module, Python Basic. So start with our first topic, Python Basic Syntax. So first of all, what is syntax? Syntax is the structure of the language. So first of all, Python is case sensitive. What does that mean? Let's see one example. Suppose I define a new variable called x. Then I define another variable also called x. But this time I use capital letter. And capital X is equal to a list of numbers, 1, 2, and 3. Okay. So now let's see if little x is equal to capital X or not. false, right? So that means little x and capital X are two different variables. So when we define variables, be careful. Python is case sensitive. Lowercase and uppercase letters are different. Let's see another example. How about values? So now let's define two new variables. Y is equal to quote A. So Y is a character variable. And Z is equal to quote capital A. Now let's see if Y and Z are equal. Apparently no, they are not equal. So Python is case sensitive. Next, let's see semicolons. Sometimes you want to put multiple statements on a single line. In that case, you need to use semicolons to separate these statements. So for example, let's create two variables and calculate the sum of them immediately. X is equal to 4, Y is equal to 6, and then X plus Y. So you see, these are actually three statements. If we want to put them in one line, we have to use semicolon to separate them. So let's run it. You see we get 10, which is correct. Next, white space. So white space in Python sometimes matters, sometimes doesn't matter. Okay, so let's see. First case, within line, white spaces don't matter actually. So let's see one example. Let's define a variable called x again, which is equal to 10 minus 5. And then we define a new variable, which is called y. So now let's insert some white spaces in between the characters. So y is equal to 10 minus 5. Then let's check if x is equal to y or not. By the way, so this double equal means comparison. So check whether or not the left term and right term are equal. So it will return a logical value, either true or false. So let's check. True, right? So white space within lines doesn't matter. So how about indentation? It actually matters. In Python, whenever we use a loop or define a function or conditional flow, we need to use a colon to start those procedures. In that case, indentations will be automatically added to your program. Let's see. For example, let's write a for loop for I in range 3, colon, print I. Okay, so this is a very mini loop, a for loop. So range 3 is a list of numbers from 0 to 2. 0, 1, 2, not including the end number, the end point actually. So let's run it. You'll see in each iteration, it will print the value of I in that iteration. So notice that after we typed this column, there is an indentation automatically inserted in the second line. So these are also white spaces, and they do matter. You have to have these indentations to indicate that this statement is within this for loop. Okay, so it's automatic. All right, next, comments. There are three formats of comments. First, inline comments. We have seen examples previously already. Let's just review it. For example, I define a new variable called x. X is equal to 5. Then immediately we can add a comment. Define a variable. And then you see whatever behind this pound key will not be shown after you run the code. Then the second format is standalone comment. So for example, we can say define a function. So later on, we will learn how to define functions by ourselves. So now let's see a very simple example. So we call the def function to define a function. Suppose we want to create a function to calculate the sum of two numbers. We can just call the function addition. And then parentheses, type the argument that are needed for the function, then type colon, then return x plus y. Then the function addition has been created, we can call it. For example, calculate the sum of 3 and 5. You see, we get 8. So apparently this is a standalone comment. Use the whole line. Occasionally, we need to insert multi-line comments. For example, you want to describe a big chunk of code in your report. So in Python, actually there is no specific syntax for multi-line comments, but you can use triple quoted strings, either single quote or double quote. For example, if we want to include 3 lines of comments, we can do the following. So notice that if I type a single quote a few times, we will see these 6 quotes. Okay, then I can hit the enter key and separate them. Then we can start to write comments. For example, this part is about regression, and we will use backward model selection to find the optimal model. Okay. And then let's type some code, random code. Print regression is fun. Then let's see what happens. Run it. So you see only this line is executed. Everything that is wrapped in this triple quote is not executed. And then next topic, parentheses. Parentheses can be used to group statements or math operations. So this is our common sense, right? For example, if you want to calculate 10 times the sum of 2 and 3, then we use this notation. We can run it and get the result. Okay. And parentheses are also used to call functions. Let's see another example. Define a list L, which is equal to 5, 4, 3, 2, 1. And then let's print the first element of L. So print, we can first print a string. The first element of L is type comma, and then let's pull out the first element. Python uses zero-based index, so if the first element has index 0. Okay, so let's run this. As you see, and the point here is we use a pair of parentheses to call the function print. And sometimes in Python, you will see that arguments are not required. Basically, you can use an empty pair of parentheses to call a function. For example, let's see. Suppose we first call the sort function to sort L. And then let's call the print function again. And see after we sort out what happened. Okay. So apparently after we call the sort function, L is sorted from 1 to 5 using ascending order by default. Okay. And after we sorted, the first value is 1 instead of 5. So the point is sometimes when you call a function, you don't have to include any arguments in the function. It looks weird, but it is allowed in Python. But actually, you see there is a default argument, which is L. Okay, we are sorting L. But when you use the dot syntax, so you start with an object and then call the method or application to apply on the object. So in that case, it seems that there is no argument. And lastly, in basic syntax, let's see how to check your version of Python installed. So first, you just need to import the sys package. So this is a built-in package. You don't have to install it. Then you can just print sys.version. You can see your current version of Python. All right. So this is part 1. Now let's move on to the second topic, Python variables. So first, let's see how to assign a variable. We can just use the equal sign. For example, x is equal to 100 and then type X. So it has been defined. So now let's pay attention to the rules for naming variables. You can use a combination of lowercase characters, uppercase characters, digits, and underscore to create a variable name. So till last example, we only use single English letters to define variables. But actually you can also use numbers and underscore. For example, let's create a new variable called my pet. Okay. So it's equal to Teddy. So this is my dog's name, Teddy. Okay. Then so my pet is Teddy. Okay. It's a character string, the value. Okay. And secondly, names of variables in Python are case sensitive. So my pet and my pet are different. So for example, if we create a new variable called my pet is Dodo. Okay. And then got my pet. So you see, and if you want to call my previous definition my pet again, you see it was not overwritten by the new definition. Okay. And thirdly, Python has a total of 35 reserved keywords. For example, if, else, def. So this is used for defining functions. And while, so this is a keyword for a while loop and for loop. So you cannot use them to define a variable. So for example, if we try to use it for is equal to 5, you see what happens. You see invalid syntax. You cannot define a variable called for. Okay, pay attention to that. Then let's see styles of variable names. For beginners, it's very helpful to have a consistent programming style. So there are two basic styles of variable names. The first one is camel case. So it's kind of like a camel, up and down. So you capitalize each word except for the first one. And snake case, just use underscore to connect different letters or words or digits, etc. So all of them work. And the last one is kind of special, is used for constants usually. If you use all capital letters, that means that variable is actually a constant. So lastly, Python variables are pointers. For many other programming languages, variables are containers, like a bucket. But in Python, variables are pointers. Let's see what does that mean. So let's first create a variable called x and let it be 1. Then probably you change your mind. You want x to be a character string, apple. Right. And finally, you change your mind again. You want it to be a list of letters, A, B, and C. So all of them are valid code. So Python will have no objection to your definition. Then let's see what x is actually equal to by typing x. So the last definition works. The previous two definitions were overwritten. So which means Python is very flexible in terms of defining variables. It's kind of like a pointer. X was first pointed to 1, the integer 1. And then you change the direction and point x to a character string apple. And lastly, you point x to a list of characters A, B, and C. Okay. Then the last definition will be the final definition of x, unless you change it again later. So that's why Python variables are pointers. And notice that in these three definitions, x has different data types and different data structures. So it doesn't matter. Python is very flexible. You don't have to predefine the data type and structure before you define a variable. So lastly, let's talk about Python operators. There are 4 types of operators: arithmetic operators, comparison operators, Boolean operators, and membership operators. Okay. First, take a look at arithmetic operators. So this table contains most of the arithmetic operators. The top 7 are called binary operators because they require 2 terms to do the operation, addition, subtraction, multiplication, division. So these are very basic. And then we have floor division, which will be the quotient of A and B round down to an integer. Okay, so let's see one example of this. So let's first calculate a regular division, 5 divided by 3. Okay, so this is the true quotient. So then let's see how floor division works. Calculate 5, floor division 3. Run it, we got 1. So we know that if we round the result in a regular way, it will follow the 0.5 rule. But floor division always round down, apparently. So it's quite special. Then let's take a look at modulus. Modulus will return remainder after division of A by B. Okay, so for example, let's check 5 modulus 3. Run it, we got 2. This is remainder of 5 divided by 3, which is definitely 2. And exponential, this is also very familiar. Let's see, 5 to the 2, okay, it's 25. There are 2 special operators listed here. They are unary operators, which means you only need to have 1 term. So negation, so this is unary minus or negation, the negative of A. Okay. So for example, let's say A is 5 and then minus A. Okay, you get negative 5. Okay. And last one is matrix product. Okay. There are a lot of more matrix operators available in Python, but in our class we rarely will use them, so I won't talk about them in details. And the second type of operators is comparison operators. Okay, we have seen double equal, right? So the value that will be returned by comparison operations is a Boolean value, either true or false. So equal. Pay attention, you need to use double equal. If you use single equal, that will be an assignment operator. You will assign the right term to the left term. So that's assignment. If you want to do comparison, you have to use double equal. And this means not equal. Less than, greater than, less than, equal to, greater than, equal to. Let's see some examples. For example, let's first create 2 variables. X is equal to 5 and Y is equal to 5. Okay, let me just get rid of the. And then let's check if X is equal to Y. Okay, true. Okay. And see another example. Suppose let's check if X is not equal to Y or not. False, okay, because X is equal to Y. So now let's define a new variable Z, which is equal to 10. Okay. And then let's compare X with Z. Okay, check if X is less than Z or not. We got true. And also, if we want to check if X is less than or equal to Z or not, we also got true, okay, because it's less than. Okay, it's one of the 2 cases, less than or equal to. All right, next, Boolean operators. Sometimes you have multiple comparison statements. For example, you want to specify some conditions in a conditional flow. You want to connect or combine multiple comparisons together. In that case, you need to use these Boolean operators. There are 3 of them, and, or, and not. So let's see, for example, we have a variable called X, which is equal to 4. Then we want to check 2 things at the same time. X is less than 6 and X is greater than 2. Okay. And the result is true. That's because both of these 2 are true. Okay. So and means intersection. Only if both of them are true, the result will be true. The next one, or. Okay. So let's see, y is equal to 21. So let's check the following two. X is greater than 10 or x modulus 2 is equal to 0. Okay. So let's check this. This one apparently will yield a false, okay, because x is 4. Okay, so false. And how about the right one? Okay. X is equal to 4. So 4 divided by 2, the remainder is 0. So 0 is equal to 0. So this one will yield a true. False or true will be true. So OR operates in that way. As long as one of the two statements is true, then the result is true. The overall result is true. So let's run it. You see true. And how about not? Not will negate a comparison result. So for example, not y is greater than 20. Right? Y is greater than 20, which is true, right? And if we negate the result, we get false. Okay. All right. Next, membership operators. There are two membership operators, in and not in. So A in B is true if A is a member of B. Okay, we'll see the meaning of member in a moment. And A is not in B is true if A is not a member of B. So let's see one example. 1 is in the list 1, 2, and 3. So check it. True, right? Because 1 is indeed one member of the list. So now let's check not in. Okay, 1 not in 1, 2, and 3. And we got false, okay, because 1 is in it. Okay, so this statement is not true. So that's why we got false. And if we check 0 not in 1, 2, 3, okay, we got true because 0 indeed is not in the list. Okay. So how about a smaller list? Let's check. 1, 2, in 1, 2, and 3. Okay. It seems that 1, 2 is in 1, 2, 3, right? Let's check it. Unfortunately, it's false. That's because in the list 1, 2, 3, each element is a single integer, is a single number. So 1, 2 itself is not one element of the list. Okay. You can say it's a kind of a subset of it, but it is not a member of 1, 2, 3. Members are these single integers. Okay. But if we define a list in this way, for example, check 1, 2 is in 1, 2, and we define a sublist here. Okay. So this is legal because list is very flexible. When we talk about data structures later, we'll talk about lists. Okay. So the third element is a smaller list called 1, 2. In this case, if we run it, we get true. Alright, that's all for this video. Thanks for watching. See you next time. Hi, today is December 16th, 2024. We will continue to talk about Python basics. Today, we will talk about building data structures in Python. So first, take a look at this table. There are 4 commonly used data structures in Python: list, tuple, dictionary, and set. So lists are ordered and mutable data collections in Python. Ordered means the ordering of elements matters. And also you can use indexes to extract elements from a list. And mutable means the content and the size of a list can be changed. Let's see some examples. First, let's create a list. Just call it L1, which is equal to 2, 3, 5, and 7. So you see that if you want to create a list, you should use square brackets and separate the elements by comma. Let's take a look at L1. And then lists have features and methods associated with it. So one important feature of a list is the length of it, because lists are one-dimensional. So it only makes sense to measure the length of. We can use the len function to check the length of a list. Let's see, the length is 4. And lists also have some methods. For example, we can append one value at the end of a list. We can use the append method. For example, let's add a value 11 at the end of L1. And then let's check L1. So one element is appended to L1. So you see that the method function will actually change the original object, the list. Sometimes we want to combine lists together or concatenate lists together. Let's see how to do it. First, let's define a new list. Then let's try to concatenate them together. We can use the plus operator. You see, it's very simple. But just pay attention, this addition or concatenate will not change L1. So let's check L1 again. So L1 still has 5 elements. It hasn't been changed since we used the append function on it. And lists can be sorted. Sort is a method for lists. Let's create a new list. Apparently it is not ordered. Now let's apply the sort function. We don't need to put anything in between the parentheses. So see, it's sorted. The sort method changed L3. And one more important feature of lists is that it's a compound object, which means the components of a list can be of different data types and different shapes. So let's see one example. Create a new list like this. So the first element is an integer 1. The second element is a character string. And the third element is a list. So this is completely fine. Okay, no problem, no error. However, you cannot sort a list with different data types. For example, let's try to sort it. And you see there is an error message. So less than is not supported between instances of string and integer. Okay, so ABC is a string, and 1 is an integer. Python doesn't know how to order them. So sort is not allowed for compound lists. Next, let's see how to index and slice a list. For example, let's pull out the first element of L1. Is 2, right? Remember, Python's index is 0 based. So the first element has index 0. And similarly, we can extract the second element of L1. And Python also has negative indexes. So the last element of a list has negative index, -1. So let's take a look at L1 again. So the last element is 11, right? So now let's try to extract the last one using a negative index. So -1. So see, it's 11. Similarly, the second to the last element can be indexed by -2. All right. Next, let's talk about slicing. Slicing means accessing multiple values in sublists. It uses a column to indicate the start point and end point of the subarray. For example, let's pull out the first 3 elements of L1. We can use the following syntax. L1, 0, colon 3. So just pay attention. The starting point is included in the result, but the end point is not included in the result. So the index 3, which is 7, will not be included. If we leave out the start index, 0 is assumed. So we can also do the following to pull out the first 3 elements. Similarly, if we want to omit the endpoint, for example, we want to pull out the element from the second one to the last one, we can do the following. And from the second to the last. In summary, we can use square brackets to index or slice a list. Next, tuples. Tuples are similar to lists, but there are two major differences. First, when we define a tuple, we need to use parentheses rather than square brackets. Secondly, tuples are immutable, which means their size and contents cannot be changed. Let's create a tuple first. Use parentheses. Okay. So see, it's a tuple. We also use comma to separate elements. And tuples are one-dimensional also. So we can also use the length function to check the length of it. So tuples are immutable. We cannot change any element of a tuple, and we cannot add or remove elements from a tuple. Let's see. Suppose we want to add one element to T. So see, we got an error message. Tuple objects has no attribute append. So in Python, different objects have different attributes associated with them. Tuple does not have the append method at all, so it won't work. Similarly, if we want to change the element, okay, for example, change the value of the first element from 1 to, originally it was 1. If we want to change it to 0, okay, so see we got this message. Tuple object does not support item assignment. You cannot assign a new value to an item. And so this is a tuple. Next, let's take a look at dictionaries. So they are mappings of keys to values, and you need to use curly braces to wrap those key value pairs. Let's create a very simple dictionary. All right. So see, when we create a dictionary, we need to specify these key value pairs. The first term is a key, and the second term is a value. And we separate these pairs by commas. And we need to use curly braces. The dictionaries are very flexible. For example, you can add a pair to it. So let's see one example. Let's add one pair at the end of students. Okay, so see, a new pair is added to the end. Items in a dictionary can be accessed through key values. So previously, when we do indexing or slicing, we use the indexes, zero-based indexes. But in a dictionary, we should use the keys to index or subset data. For example, if we want to access the value of the second pair, we can do the following. You see, Jimmy is the second value. All right, that's all about dictionary. Now let's move on to sets. So sets are unordered collections of unique items. So which means ordering does not matter for those elements. And a set can only contain unique values. So let's see a few examples. So first, let's create two sets. We first create a set of prime numbers. Oh, by the way, we should use curly braces to wrap the elements. And then we create another set which contains some odd numbers. So I intentionally added one repeat value for 1. Okay. So now let's print both of them. So first print primes, okay. And then let's print odds. So see, automatically the repeated value was removed because by definition, a set cannot contain repeated values. And now let's take a look at some set operations. So there are a few basic set operations. You probably are already very familiar with them. The first one is union, which means you pull all of the elements of two sets together. In Python, there are two ways to do union. First is to use an operator. For example, suppose we want to find the union of primes and odds, we can just use the vertical bar operator. So this means union. And you see, pay attention, the union of two sets is still a set, so it does not contain any repeated values. This is consistent to the definition of union in probability. Alternatively, we can use the union method. For example, we can take primes, then dot union, and add odds. Okay, run it. We get the same result, right? So this is a dot method. And you take one object and then dot method, and then add the other object. What if we take odds first, and then apply the union method, and then primes? As you see, we get exactly the same result. Okay, so union is a symmetric operation. It doesn't matter which set you first specify. All right. Next, intersection. In Python, we can use the AND operator to find the intersection. So see, intersection can be found in this way. Alternatively, you can use the intersection method. Okay. And again, this is symmetric. We can do the following: odds dot intersection primes, and get the same result. And then let's talk about set differences. So let's copy it here to remind us what the two sets are. So now let's calculate the difference between primes and odds. We can use the minus operator. So this means primes minus odds. Okay, let's see what happens too. Okay, so we know that the intersection between primes and odds are 3, 5, and 7. So set difference between primes and odds is just like taking the prime set and remove the intersection between primes and odds from primes. And whatever left is the set difference between primes and odds. So it's somehow like removing any elements in odds from the primes set. And then let's check if we take odds first, what happens. Okay. Apparently the result is different. So it works in this way. Take odds, the odds set, and remove any elements from primes from it. So 2, 3, 5, 7 will be removed. Of course, 2 is not there, but 3, 5, 7 will be removed from odds. And also repeat value will be removed too. So 1 and 9 will be left. Okay. So clearly, set difference is not a symmetric operation. We can also use the difference method to calculate that difference. The operator is the hat key. Let's see, primes, hat, os. Okay. So the symmetric difference is the set of elements that are in only one of the two sets. So they are either in primes but not in os, or in os but not in primes. Okay. So that's why it's symmetric. We can check it. Os, hat, primes. So there is also a symmetric difference method. Okay. And you can also change it the other way. Alright, that's all for today. And next time, we will talk about NumPy data structures, vectors, matrices, and arrays. Thanks for watching. See you next time. Hi, today is December 19th, 2024. We will talk about NumPy vectors, matrices, and arrays. NumPy is a very important package in Python because it provides some very important data structures in machine learning, such as vectors, matrices, and tensors. So first, let's see how to create a vector. We need to load the NumPy package first. To load the package, we use this kind of grammar. Import the package name as a shortcut name for the package. We usually create an abbreviation for a package when we load the package because later on we need to refer to the package name whenever we call a function from the package. So to save time and effort, we usually create an abbreviation first. For NumPy, a commonly used abbreviation is NP. So we just follow the convention. First, let's create a row vector. We can just use NumPy's array function. Okay. So the syntax is np.array. So which means the function array is from the NumPy package. Then in the parentheses, we can just put a list in it. For example, we wanted to include 1, 2, and 3 only. And then we're done with the definition. And then let's print the vector. So see, a row vector in NumPy is very similar to a list. However, there is no comma in between any two values. Let's check the dimension of a row vector. We can use the ndim function. So this is a method associated with NumPy arrays. Let's check it. 1. So a row vector is a one-dimensional array. How about column vectors? So suppose we want to create a column vector with 1, 2, and 3 in it. We should do the following. Okay. So see, this is a column vector. So notice that we need 2 layers of square brackets. So each element is assumed to be a row of the column vector. We need to use a square brackets to denote that it is a row in the column vector. Okay. So now let's check the dimension of a column vector. It's still called the ndim method. 2, right? So a column vector is actually a two-dimensional array in NumPy. It's not one-dimensional anymore. And the syntax is like this. We need 2 layers of square brackets. So actually, NumPy's main data structure is the multi-dimensional array. So either one-dimensional, two-dimensional, or even higher dimensional. However, in machine learning and data science, we rarely use 3 or more dimensional arrays. That's because it's very difficult to understand and to create a higher dimensional array. So let's move on to matrices. We know that matrices are 2-dimensional arrays. We can use NumPy's array function again to create a matrix. For example, let's create a 3x2 matrix, which means there are 3 rows and 2 columns. We can call it M1, so it's 3 by 2, 3 rows and 2 columns. So see, the syntax is similar to the one we use for a column vector. However, now in each row there are 2 elements. So this is a matrix. NumPy actually has a specific function to create a matrix. The function is called mat, M-A-T. So we can actually we copy the code above and call it M2. So we can change the function's name from array to mat. And then let's run it. Okay. So see, it works. So although the mat function is available in NumPy, it is recommended to use the array function instead. So that is because arrays are the standard data structure of NumPy, and also most of the NumPy operations return arrays, not matrices. So just directly use array instead of using mat. So in data science and machine learning, many times the data is very sparse, which means in a data matrix, most of the values are zeros. There are only a few non-zero values. So in this case, it will be more efficient to represent the matrix using some other formats. For example, consider the following sparse matrix. Okay, so it's a 3x10 matrix, but only 2 values out of the 30 are non-zero. So you see we have a 1 here, a 3 here. So how to make it a compressed sparse matrix? We can use a function from the SciPy package. So let's first import the package and the function. So we actually will import the function directly from SciPy import sparse. So this is actually not one function, it's a family of functions. We will use one function from this family. And we will do the following. Let's call it M3 sparse. And then the function is called CSR underscore matrix. Okay. Then put M3 in it. So let's run it. You see, this is how it looks like. So this is the M3 sparse function. So instead of showing all of the details of a matrix, it only shows the coordinate and the value of each non-zero element. Notice that 1 is in the second row and second column. So the coordinate or the indexes of it is 1 and 1. And 3 is in the third row and first column. So the indexes are 2 and 0 respectively. Apparently by storing the matrix in this way, we save a lot of space in our computer, and also the computation will be more efficient. Let's move on to selecting elements from arrays. First, row vectors. So because row vectors are one-dimensional, we only need one index to specify the element or elements. So for example, we define a row vector v1 with 6 numbers. So let's try to extract the first element of v1. We can also use the square brackets to extract single values. And because NumPy arrays are also 0 indexed, the first element has index 0 instead of 1. If we want to select every element up to and including the third element, we can do the following. Okay, so the first 3 elements are extracted. Notice that the endpoint is not included. You see, index 3 is corresponding to the number 4, but it's not included in the result. Similarly, we can select all the elements after the third element. So this is included. So index 3 is corresponding to 4. So this is exactly the first element after the third element. Then let's move on to matrices. Since matrices are two-dimensional, we need to indicate both the row and column indices of the elements to be selected. So now we create a new matrix called M4, which is a 3x3 matrix. Suppose I want to extract the value 5 from the matrix. So 5 is in the second row and second column. So we can do the following. Because index 1 is corresponding to the second row, okay, and second column. We can also slice matrices by specifying multiple rows or multiple columns. As for example, suppose we want to select the first 2 rows and all the columns of a matrix. We can do the following. Column means everything, okay? And column 2 means the first 2 rows starting from 0 and then 1 and 2 is not included. So first 2 rows and all the columns. Similarly, we can also select all rows and the second column. So notice that this is in a row array format. If you want the result to be a two-dimensional array still, you can do the following. So see, then we still have a two-dimensional array or a matrix. Okay. Just it only has one column. To describe the features of a matrix, such as the shape, size, dimension, we can use some built-in methods in Python. For example, we create a new matrix, M5, which is a 3x4 matrix. And then let's check the shape of it. So the method is just called shape, and there is no parentheses because there are no other arguments for this method. So it shows you the dimension of the matrix. We can also check the size of a matrix. What is the size of a matrix? Let's see. 12. 3 times 4 is 12. So the size is actually the number of elements or values in a matrix. And lastly, we can still check the dimension of a matrix. This is also a feature of a matrix. It's two-dimensional, no surprise. Alright, now move on to the next topic, applying operations to elements. So in this small section, we will emphasize one important feature of NumPy arrays, which is called broadcasting. So NumPy arrays allow us to perform operations between arrays, even if their dimensions are not the same. So for example, if we want to add 100 to each element of M5 is this matrix, just add 100 to each element, then we can just do the following. So see, we add 100 to each element of the matrix. So the syntax is very simple. So this is called broadcasting. Similarly, we can multiply each element of M5 by 10. It's similar to R actually. Next section, we'll see how to calculate some basic summary statistics of an array. So first, find the maximum and minimum values. We can use NumPy's max and min functions. For example, we know that M5 looks like this, right? Let's print M5 to remind us how M5 looks like. Okay. Then let's calculate the maximum value of M5. So we call the max function in NumPy. So apparently 12. Okay. So apparently the max function in NumPy will ignore which row and which column a value is. It will treat all elements the same way and calculate the maximum. Similarly, we can calculate the minimum of them. And there are some other useful functions in NumPy. For example, mean, variance, and standard deviation. Let's see. So the mean function will calculate the average of all of the values in a matrix or an array. We can also calculate the variance. And standard deviation. Very simple. Right? Sometimes for matrices, we're interested in summarizing the data along the rows or columns. So we just need to add the axis argument in each function to specify how the calculation should be performed. For example, suppose we want to calculate the maximum of each column in M5. We can do the following. So we first print out M5 to better understand the operations. So suppose we want to calculate column maximum. Specify M5 and then specify the axis. Axis equal to 0 is corresponding to column. So see, the first column has 1, 5, and 9. The maximum is 9, right? Similarly, the second column has 2, 6, and 10, so the maximum is 10, etc. So just remember, in NumPy, axis equals 0 means we are doing the calculation along the column. Similarly, if we want to calculate the row maximum, we can do the following. Just copy the whole thing and paste it here and modify it. Change axis to 1, and 1 is corresponding to row, the horizontal direction. Okay. So see, the first row has 1, 2, 3, 4, so the maximum is 4. We can also calculate some other statistics row-wise or column-wise. For example, we can calculate column means and row means. Let's see, 1, 5, and 9. The mean is 5. Okay. And we can also calculate row means. Change the axis to 1. Okay, so let's see. Next, reshaping arrays. Sometimes we want to change the shape of an array without changing the elements. So let's first take a look at M5 again. Suppose we want to change it to a 4x3 matrix. We can do the following. Okay, so see, we're done. Notice that the reshape function will not change the ordering of elements, still from 1 to 12. Just now, each row has only 3 elements, and consequently we have 4 columns. So the total size won't be changed. By the way, the reshape function will not change the original matrix M5. Let's check after applying the reshape function how M5 will look like. So it's still a 3x4 matrix. So if you want to save the result, you can give a new name to it. For example, we can call it M6. And then if you print M6, it will be a 4x3 matrix. A very useful argument in reshape is -1. So this means as many as needed. So you only need to specify the number of rows or the number of columns and use -1 for the other dimension. Suppose we want to reshape M5 to a new matrix with 2 rows only. And suppose I don't know how many columns I need. Then we can do the following. M5.reshape 2 rows and -1. And then you see the new matrix has 2 rows and 6 columns because the total size cannot be changed. 12 divided by 2 is 6. We can also flatten a matrix using the reshape function. For example, we can just slightly modify the code. Okay, change 2 to 1 so that the result only has 1 row. Okay, so this is the result. And sometimes we want to flatten a matrix, which means change it from a 2-dimensional array to a 1-dimensional array. Then we can call this flatten function. And then we have a 1-dimensional array. So what's the difference between the result of the flatten function and the result of reshape 1, -1? If you pay attention to the 2 results and compare them, you see that there are 2 layers of square brackets in the result of reshape, but only 1 layer of square bracket in the result of flatten, which means the result of the reshape function is still 2-dimensional. It's a matrix, but it only has 1 row. But the result of the flatten function is a 1-dimensional array. You can check the dimension if you want. Now the last topic is transposing a vector or matrix. So let's see one example. Let's first print M5 again. It's a 3x4 matrix. So if we transpose it, so the method is just called T, capital T. So if we do this, you see we have a 4x3 matrix now. And each original row becomes 1 column in the new matrix after transposing the original matrix. And pay attention, 1-dimensional arrays cannot be transposed. You can still apply the T method on it. However, it won't change anything. For example, V1 is a one-dimensional array, is a row vector, right? Let's try to transpose it. Okay, you see it's still a one-dimensional array. It won't be changed. However, if you have a matrix with only one row, then you can transpose it to a matrix with only one column. For example, let's define a new vector, call it V3, and then let's print V3. So this is a row vector still, but it is two-dimensional. Then it makes sense to transpose it. Now we have a column vector with 6 elements. So this is basically a matrix still with only one column. Alright, that's all for today's video. Next time we will talk about packages, how to install a package in Jupyter Notebook, and how to import packages. There are different ways to import a package and the functions of a package, and they are slightly different. We'll talk about which one is the best choice and which one is the worst. See you next time. Hi, today is December 20th, 2024. In today's tutorial, I will show you how to import Python modules or packages. So Python has two types of modules or packages. The first one is the standard library. This one provides a lot of useful tools for a wide range of tasks. And the second type is third-party tools and packages. So they offer more specialized functions. So let's see how to load modules. We have seen examples of loading modules using the import statement. And actually, this is the main statement that we can use to load modules. There are 3 ways to import modules: explicit import of a module, explicit import of module contents, implicit import of module contents. So you might wonder, what's the difference? They all look so similar. It's kind of confusing, right? I will show you details about each of these 3 ways. And also I want to point out that the first way is the most recommended, and the last one is the least recommended, and the second one is in between. First, explicit module import. So this is the most commonly used one, and it preserves the module's content in the namespace, and the basic syntax is module.content. The content can be a function, a method, a constant, etc. Let's see one example. Suppose you want to import a math module. You can just do this, import math. And then you can use all of the functions and constants, etc. in the module using this dot syntax. So for example, if you want to calculate the cosine of pi, we can say math.cosine, math.pi, parentheses, of course, and it's equal to -1. The syntax is very clear. You know exactly which function you are using and where the function is from. So it's very specific, very clear. And also, the constant pi is from the math module. That's why it's highly recommended to use this way to import a package. Sometimes module names could be very long, and if we use this explicit import, we have to refer to the module name each time we call a function or use a constant. So that motivates us to create a shorter alias for the namespace or the module. The basic pattern is import some module as an abbreviation of the module. We have seen this before. For example, if we want to import the NumPy package, we can at the same time create an alias np for it, and then we can use np when we refer to the package. For example, we still want to calculate the cosine of pi, but now I want to use the cosine function and pi constant in the NumPy package. Then we can just do the following. So you see, both the math module and the NumPy module have these two items, the cosine function and the constant pi. Then let's move on to the second way, explicit import of module content. Sometimes you want to import a specific set of items from a module. In this case, you can use the following pattern. From a module, import specific items. For example, we can import the cosine function and the constant pi from the math module by using this code. From math, import cosine and pi. And you need to separate the items by comma. Then, if we use this way to import the package, we can directly use the function and the constant from the module. You see that the syntax is more concise because we don't need to refer to the math module again. However, there is one potential problem. After we do this kind of importing, the cosine function and the constant pi from other packages will be overwritten. However, this case is not too bad because we know exactly which function and which constant from which package are overwriting the same name functions and constants. So this is in the middle. It's not the best, but it's not the worst. Now let's see the third way, implicit import of module contents. So sometimes it's useful to import the entirety of the module contents into the local namespace, which means you import everything in a module and make all of them available in your workspace. The basic syntax is from a module import asterisk. So asterisk means everything. For example, we can from math import everything using asterisk. Then you can use all the functions, all of the methods and constants from the math module. But apparently, one drawback is that because you make all of these available in your current workspace, all of the functions with the same names will be overwritten implicitly by doing this importing. So that's why this pattern should be used sparingly, if at all, just because of this implicit overwriting action, which is kind of risky. So this is the least recommended. Finally, third-party modules. To import a third-party module, we just need to use the same method using the import statement. However, before you import the module, you have to install it on your system. And the standard registry for such modules is the Python package index or PyPy. You can find them in this web page. And for convenience, Python comes with a program called pip, so which will automatically fetch packages released and listed on PyPy. So let's see, it's very convenient to use this pip installation. For example, if you want to install a package called Super Smoother, you can just type this pip install Super Smoother in your Jupyter notebook, and the source code for the package will be automatically downloaded from the PyPy repository, and the package is installed in the standard Python path in your computer. Okay, so it's a very convenient process, but you might need to quit Jupyter notebook and reopen it if you want to import the package and use it. Alright, that's all for this tutorial, and next time we'll talk about how to import data. Thanks for watching. See you next time. Hi, today is Saturday, December 21st, 2024. I've been teaching data science courses at the university for 8.5 years. Surprisingly, many students still struggle with correctly importing data even by the end of the semester. This makes me believe that this topic is well worth discussing. So today, we'll talk about importing data. This is an outline of today's video. So we will talk about how to load data from a variety of sources, including online resources and local resources. And we will also talk about how to import a data set from a package. So first, importing a CSV file. We can use pandas libraries read_CSV to load a local or online hosted CSV file. So CSV means comma separated file. So let's first take a look at how to load a file from an online resource. So first we need to import the package pandas and give it an alias PD. So PD is the commonly used abbreviation for pandas. And then let's create the URL where the file is saved. So this is the URL. I call it URL1. Then we can call the function read_CSV from the pandas package and just put the URL in it. Call it data frame 1. And then the loading process is done. We can take a look at the first few rows using the head method for data frames. Pay attention, this head method is associated with pandas data frames only. So only if the data set is a pandas data frame, we can call this method. Okay. So see, these are the first two rows of the data set. 3 variables, integer, datetime, and category. This function read_CSV has over 30 parameters, but most of them have default values, so we don't have to specify each parameter when we call this function. For example, in our code, we only used one parameter, which is the URL. So this function assumes that comma is the separator, but we can also specify other separators using the SEP parameter. Sometimes CSV files use other separators, such as semicolon. In that case, you can use the SEP parameter to specify the separator. And also, this function assumes that the first line has the column names or column headers. And if that is not true, you can use the header parameter to adjust it. So if there is no header, you can just set header equals none. But by default, the first line contains the column names. Then I see how to import a local CSV file. And so suppose I have a data set saved in my local folder. So you see it's in my Dropbox and data flow channel, etc. in the data folder. And the file is Apple quality. It's a CSV file. Then how to load it? We can copy this path and paste it in a pair of quotes, and make sure that you add the file name and the extension of the file. And also you need to change the direction of the slash. So when we copy it, it is backward. We need to change them to forward. And we use the same function, read_CSV from the pandas package. Other things are the same. Just instead of using an URL here, we use the directory of our local folder and the file name. Alternatively, we can upload the data set to our local Jupyter folder. And then in that case, we can omit this path, just directly type the name of the data set. So let me show you. Okay, so I uploaded the data set to the local folder where I save my Jupyter notebook. So see, the Jupyter notebook I'm using now is this importing data, right? So how to upload a file? Let me first delete it, and then I'll upload it. So click upload, and then locate the file, and then click open, and then click upload, and then you see the file is uploaded to the local folder, which contains my Jupyter notebook importing data. In this case, we can omit the entire directory and only specify the dataset name. Then let's move on to Excel files. So Excels are similar to CSV files, except that Excel files have multiple sheets, probably. Consequently, when we load an Excel file, we need to specify the sheet name, specifying which sheet we are going to import. So the function is called read_Excel. It's still in the pandas package. Suppose this is an online data set. We can specify the URL and then the sheet name. Notice that it is still 0 indexed. So the first sheet has index 0. Header equals 0 means the first line contains the headers of those columns. Okay, so we can load the data this way. There are some notes here. Okay, so sheet name can accept both strings containing the name of the sheet and integers pointing to the sheet positions, 0 based. And you can also load multiple sheets at once. You just need to use a list to wrap all of the sheet names. So for example, this is legitimate. I specify 012, which means we will load the first 3 sheets, and a sheet named monthly sales. So it will work. Next, loading a sample data set. Many packages come with some commonly used data sets that we can quickly load. So these data sets are often called toy data sets because they are very clean and easy to handle. So let's see. So first, the scikit-learn package has some very good data sets. Scikit-learn is for machine learning, and there are 3 very popular data sets. Load Boston. So this one contains observations on Boston housing prices. So it is good for exploring regression algorithms. The response variable is a numeric variable. And Load Iris contains observations on the measurements of iris flowers. It is good for classification algorithms. And Load Digits is good for teaching image classification. So let's take a look at Load Iris. So first, the package scikit-learn is called sklearn. And import the data set. And then we load the data using this syntax. So datasets dot load iris. And this iris is a comprehensive object which has a lot of components. And among those components, there is a data component which contains the x and y variables. The features variables are the x variables or explanatory variables. So in the iris data set, the features are the width and length of sepals and petals, so 4-dimensional, 4 columns. And the target variable or the response variable is the species of the flower. Okay, so we can load it. So you see in the scikit-learn package, all of the data sets are saved in this way. The features and the target variables are stored separately. So when you load them, you need to load them separately. Let's check the shape of the features data set. Okay. 150 rows and 4 columns. Okay, so 4 features, 150 observations. Similarly, we can check the shape of the target vector. Okay, so it's 1-dimensional. You see, so there is only 1 index, 150 observations, okay, and 1 column. We can create a scatter plot for the first 2 features variables, sepal length and sepal width, okay, using matplotlib's pyplot submodule, okay, to create it. Okay, we'll talk about visualization later. And then let's take a look at another package called Seaborn. Okay, Seaborn is a package for creating graphical displays. It contains a lot of high-level functions that we can use to create very beautiful plots. So it comes with some data sets. For example, tips. So the syntax is, first we import the package, Seaborn, and give it an alias SNS, and then call the load dataset function and specify the dataset you want to load. Okay. We call it tips. And then we can use the head function to show the first 5 rows of the data set. Now pay attention, Seaborn data sets are pandas data frames. So we can use the head method to show the first few rows. But scikit-learn's data sets are not data frames. Consequently, we cannot use the head method to show the first few rows of them. Okay. We need to use some other functions. Seaborn also has the iris data set. Okay, so you see we can load the iris data set, call it iris, and because the dataset in Seaborn are data frames, pandas data frames, we can use a head function to show the first few rows. Lastly, the stats modules package also come with some data sets. For example, one of them is called state crime. We can use this syntax to load the data. First, from stats models, import the dataset submodule, and then specify that we want to load states crime, this dataset, and use load pandas method, which means we want to use the pandas data frame format of the data, and then .data. Because it's a pandas data frame, we can use the head method to show the first 5 rows. So you see, this data set contains state crime data, violence, murder, high school graduate, poverty, and each row is corresponding to a state. Alright, that's all for today's video. Next time, I will show you how to explore Kaggle data. So Kaggle is a very good website for data science and machine learning computations, and it has a lot of free data sets available. But for beginners, it's kind of tricky to find appropriate data sets to play with because there are just too many data sets. So in the next video, I will show you how to filter out good quality data sets that are appropriate for beginners in data science. See you next time. Hi, today is still December 21st, 2024. In this video, I will show you how to search, filter, and download datasets from Kaggle. Kaggle is a great resource for datasets. It's open source, so anyone can upload and download datasets for free. Let's get started. Let's first search for Kaggle. And the very first link is the website for Kaggle. And then you might want to search for datasets directly. For example, if we click datasets, we get to this page. And then there are so many datasets. So first category is trending datasets. And then LMM, fine tuning. So datasets are categorized for us for different purposes. And for beginners, I suggest you to use filters so that we can find appropriate datasets for us to play with. So first, for beginners, I suggest you to use smaller dataset. So let's set the maximum to be 1 MB. And then file type, I would choose CSV because it is the easiest type to deal with. And then we don't need to worry about the licenses. And usability rating, let's set it to be 10. So the data will be very clean and very easy to handle. And then highly voted for what? Let's check learning and apply. Then we'll see 47 data sets satisfy all of these 4 conditions, and they are ranked by hotness by default. Okay. So customer shopping, student depression, etc. We definitely can change the ranking standard. For example, we can change to most votes. So then you see the dataset with the most votes is the number 1. However, usually these datasets are kind of old. You see, updated 5 years ago. And if you want to use newer datasets, just click New. So then you see the top one was updated a month ago. So let's open a dataset. Let's see, how about this one, student depression dataset. Click it, then you see there is some data description here. I read it and view more. Usually the features variables and target variables are listed separately. And notice that some variables don't have description. This is not very ideal. So let's go back and check another one. So how about this, student performance? So take a look. Okay. Right. So this one looks better. All of the variables have interpretations. And then let's scroll down. So 10 of 10, there are 10 columns in the data set. And in the detail part, you can see the name of the variable and also a very simple graphical display for each column. Not everyone. So gender has 2 categories, 0 and 1, and lunch, 0 and 1, etc. And also the values are listed. I personally prefer checking the columns. So click column, and then you see there is detailed description for each column. The first variable is gender, and then 1 for male and 0 for female. And also valid observations 1000, mismatched 0, missing 0. So for this variable, there is no missing value, which is really good. There are some summary statistics calculated for us. For example, the mean, the standard deviation, and the 5-number summary, minimum, Q1, median, Q3, and max. Similarly, the second variable has still no missing values. Okay. And this one is a categorical variable. So for this variable, the number of unique values is provided, 5. Okay. And then most common, group C. So 32% of the observations fall in this category. So this is the mode of this variable. Okay. And then you can scroll down and see there is no missing value in this data set at all. So this is a completely clean data set. Very good for beginners. So then if you are satisfied with this data set, you can download it. And usually I just download the data set as a zip file. And then you see you are prompted to either sign in or register. So if you want to download the dataset from Kaggle, you need to register first, but it's totally free, so no worry. Then let me show you some other ways to search dataset. So notice that there are some keywords here. For example, if you want to search some dataset about computer science or education, etc. Or you can, for example, you want to search some marketing data, then you can search marketing, and then all of the data sets are here. And then you can furthermore set some filter standards. So let me choose 8 or higher this time, and learning. And see, let's take a look at this one, usability 8.2. Let me show you data set with missing values, potentially. Well, actually this one is still clean. We can also search data set according to the problem. If it's a classification problem, namely if the response variable is categorical, we can click this and then start filter. So let me ignore this highly voted for. Then you see this is the result. Okay. So the first one is air quality and pollution assessment. Let's click it. I want to mention a few other things. So you see the default tab is data cards, but there are some other tabs available. Code. You will see some postings of other people who use this data set to do personal projects. They are very good resources for beginners to learn how to code using Python. Most of the postings are in Python. Occasionally you will see people who use R. So let's open one of them. So usually I will click the first field. So they are ranked by hotness. Hot means popular. You can see how they handle the data and how they create graphical displays. And finally, they probably will also do machine learning modeling. Okay. You see random forest. I just think it is a very good resource for beginners to learn data science and machine learning. Alright, that's all for this video. Next time, we will start to talk about conditional flows. If, else, and else if in Python. And after that, we'll talk about loops, for loops, while loops, and then we'll talk about Python functions, built-in functions, how to call them, how to use those functions, and how to define our own functions. Thanks for watching. See you next time. Hi, today is December 24th, 2024. We will talk about conditional statements, the if, else if, and else statement. So conditional statements allow us to execute certain pieces of code depending on some Boolean conditions. Let's first review Boolean operators. Equals. we use double equal to denote the comparison statement, and then not equals, less than or equal to, greater than or equal to. First, the if statement. Let's take a look at this example. X is a variable which is equal to -5. Then let's write an if statement. If x is less than 0, colon, print -x. Notice that indentation will be automatically inserted in front of the second line after the colon. So let's run this. 5, right? Because x is -5, x is less than 0, we print -x, which is 5. So the if statement is very simple. You put the condition here and then colon, and then in the second line, put the statements you want to execute if the condition is true. And notice that if the condition is not true, then nothing will happen. Let's take a look at another example. X is equal to 5. So in this case, the condition is false. Consequently, we don't expect to see any output. Let's run it. So see, nothing happened because the condition is false. Okay, so the statement will not be executed. Then let's see some notes about the if statement. So first, the if statement without indentation will raise an error. Let's see this example. This is the correct syntax. Let's intentionally remove the indentation. Then let's run it. So see indentation error. Expected and intended block. Where? Yeah, in front of the print. Okay, you see it's marked here. Okay. So the error message is pretty intuitive and easy to understand. And if we add the indentation back, usually we use 4 spaces. And then let's run it again. Okay, so no error anymore. Secondly, if you only have one statement to execute, you can put it on the same line. So A is equal to 12, B is equal to 6. Okay. And if A is greater than B, print A is greater than B. So there is only one statement to execute. In this case, to save space, we can put them in the same line. Of course, in this case, we don't need to have any indentation. Let's execute it. The second statement is else if. In Python, it is elif, a shortcut of else if. So this keyword means if the previous conditions were not true, then try this condition. So if other conditions above the current statement were false, then try the following condition. Let's see one example. So A is equal to 12, B is equal to 12, and if A is less than B, print A is less than B. Else if A is equal to B, print A is equal to B. So notice that if A is less than B is false, then check if A is equal to B or not. If it is true, print it. And if A is greater than B, for example, then nothing will happen, right? So in our example, A apparently is equal to B. So this statement will be executed. Okay, let's check it. Okay, so indeed, A is equal to B. So that is how else if works. If the previous condition is not true, then check this condition. And if it is true, execute the following statement. The last statement is else statement. So the else keyword catches anything which isn't caught by the preceding conditions. Sometimes we only need a pair of if and else statements if there is only one condition. For example, x is equal to -3, and we just want to check if x is negative or not. If it is negative, then y is equal to -x, else y is equal to x. In other words, y is the absolute value of x. Okay. So print the absolute value of x is y. Okay, let's see how it works. Okay. Since x is negative, So this condition is true. So y is equal to negative x, which is 3. Then print the absolute value of negative 3 is 3. Sometimes we need to use all of them at the same time. Let's see the next example. We'll first import the NumPy package as np and let x be the pi constant. Let's see this conditional flow. If x is equal to 0, print x is equal to 0. Else if x is greater than 0, print x is positive. Else x is negative. So in this example, it's very obvious that the else statement will collect all the cases that do not satisfy the previous conditions. So let's run this conditional flow. Pi is positive. Right. So the second case is true. X is greater than 0. Now let's take a look at compound conditions. Sometimes you have 2 or more conditions in the if statement or the else if statement. Let's first briefly review the 3 Boolean operators we learned before. We can use these operators to connect or combine conditions. First, AND. Condition A and B is true if both A and B are true. Okay, so only true and true will yield true. Or A or B is true if either A or B is true, or both A and B are true. So in other words, at least one of A and B is true. Lastly, not A is true if A is false. Okay, so this is a negation. Let's see some examples. First, the AND operator. So we define 3 variables. A is 200, B is 33, and C is 500. Okay. We will check 2 conditions. A is greater than B, and C is greater than A. Okay. Apparently, both of these 2 conditions are true. Okay. So if these 2 are both true, then print both conditions are true. Otherwise, at least one condition is false. So let's run this. Okay. Both conditions are true because we know A is greater than B, and also C is greater than B. So both of them yield true. So true and true will yield true. Okay. Then let's take a look at OR. Okay. Still, we define 3 variables, A, B, and C, with the same values. And then we check if A is greater than B or A is greater than C. If one of them is true, then we print at least one of the conditions is true. Otherwise, we print both conditions are false. The combination of 2 conditions have 4 cases. True and true, true and false, false and true, and false and false. Right? Only the last case, false and false, will yield a false if we use OR to combine 2 conditions. That's why both conditions are false is the only case that this is false. Let's move on to NOT. So A is equal to 33, B is equal to 66. Then if not A is greater than B, print A is not greater than B. Else A is greater than B. So the NOT operator will negate the condition. In this case, A is less than B, right? So A is greater than B will yield a false. Then not this will yield a true. Consequently, this one will be executed. Okay. Otherwise, print A is greater than B. Let's run the cell. Okay. So A is not greater than B, which is true. Next, let's see raise errors. Sometimes, even if we considered all of the cases for the conditions, there might be some errors because maybe the type of the data is completely wrong. For example, we want to check if a variable is positive, negative, or 0, but there is a condition x is numeric. What if x is actually a character string? Then none of the conditions will work. In this case, we will add one more case where the data type is not correct. We will raise some value error. So Python allows us to raise value array using the raise statement. Okay, so for example, x is equal to hello is a character string. And we first check if the type of x is not in integer or float. So together, this includes all of the real numbers. If x is not numeric, then raise the value array. X must be a real number. And if this is not the case, that means x is a number, then we can go ahead and check the conditions equal to 0, greater than 0, and else, which is less than 0. So now let's run this. Because x is not numeric, we see this value array, x must be a real number. Lastly, let's briefly talk about defining a simple function. I will create a video for defining functions later, but for now, let's just define a simple function because conditional statement is a building block of self-defined functions. So let's just try it first. Okay. So we define a function to return the absolute value of the input. To define a function, we just need to call the def function and then give a name to the self-defined function. Let's call it absval, which stands for absolute value. And there is only one input for the function. And then we just put the conditional flow in the function. All right, let's define this function. It works. And immediately we can call this function. For example, we want to calculate the absolute value of -7. Then we can run it. 7, right? Next, let's check if we enter a letter A, what will happen? So a value array will be raised. X must be a real number. Alright, that's all for this video. Next time, we will talk about Python loops, for loops, and while loops. See you next time. Hi, today is December 25th, 2024. Merry Christmas. In this video, we will talk about loops. So loops are used to avoid repetitions in coding. We will talk about two types of loops. The first one is for loops. For example, if we want to print each element in a list, we can use a for loop as follows. For I in the list column, print I. And let's run this chunk. As you see, all of the numbers have been printed. And this n equals space is used to put all of the numbers in one line. Without it, the numbers will be in a vertical column and it will occupy more space. Now let's examine the for loop in details. So in the for loop, we specify the looping variable I and the sequence we want to loop over. So in our example, I is a looping variable, and you actually can use any letter. Just make sure that you use the same letter in the for statement and in other statements which involve the looping variable. You can use J, K, whatever you like. And this is the looping object. In our example is a list. And lastly, we use an in operator to link them together. So for I in the list. So in the first iteration, I is equal to 0. So we will print 0. In the second iteration, I is equal to 1. So we'll print 1, etc. All the way to the last element, which is 4. So the last number is 4. The object after the in operator can be any Python iterator. So what is an iterator? An iterator can be thought of as a generalized sequence. So for example, in the following for loop, we use an iterator generated by this range function, range 5. The range function starts at 0 by default, and then by convention, the top of the range is not included in the output. So range 5 is actually a list of consecutive positive integers from 0 to 4, and this is an iterator. Then let's take a look at the range function. The standard syntax is range start, stop, step. For example, if we want to start from 1, we can specify the start value here. So let's run it. You see, starting from 1 and end at 10. So the endpoint will not be included. We can also change the step. For example, we can create a list of even numbers between 0 and 10. And let's run this. So this is a list of even numbers. Sometimes we need to use multiple layers of for loops. Let's see this example. So we first import a NumPy package. Then we create an empty matrix or two-dimensional array using the empty function. You just need to specify the number of rows and number of columns in the array, and then we call it M. Then let's see this nested for loop for I in range 1 to 5, for j in range 1 to 5, mi minus 1, j minus 1 is equal to I times j. So basically, we will fill each cell in the matrix one after the other. And the rows are corresponding to the outer loop, and the column index is corresponding to the inner loop. So let's run this chunk first and then explain it. And then let's print M. So it looks like this. So let's see how this nested for loop works. In the first iteration of the outer loop, I is equal to 1. And then j can be 1, 2, 3, 4. So, and you see when I is equal to 1, then I minus 1 is 0. So that is corresponding to the first row. So j will be equal to 1, 2, 3, 4. So j minus 1 will be 0, 1, 2, 3. When I is equal to 1, we are filling the 4 cells in the first row. And then I is equal to 2, we are filling the 4 cells on the second row, etc. So this example might not be very obvious about the ordering of the loops. Let's see another one. In the outer loop, I loops over A, B, and C. In the inner loop, J loops over 1, 2, 3, 4. And then we'll print IJ. So let's run this. So see, now the ordering is very clear. So for each value of I, j is equal to 1, 2, 3, and 4. And then I will be equal to b, and j will be 1, 2, 3, 4 again. So it's very obvious how the nested for loops works. Now let's take a look at while loops. A while loop iterates until some condition is met. For example, let's see this while loop. I is equal to 0, while I is less than 5, print 2 to the I. And then I plus equal 1. So this means I is equal to I plus 1. Basically, we add 1 to I at the end of each iteration until this condition is not met. So let's run this. You see, I starts from 0. 2 to the 0 is 1. And then I is equal to 0 plus 1, so 1. I check condition. 1 is less than 5, so the condition is good. So print 2 to the 1, which is 2. Okay. Then I is equal to 1 plus 1, which is 2. I check condition, still met. And 2 to the 2 will be 4, etc. until I is equal to 4. When I is equal to 4, 2 to the I will be 16. And then I is equal to 4 plus 1, which is 5. Then the condition is not met and the loop is ended. Some notes. The condition of the while loop is evaluated as a Boolean statement, which means this statement should yield a true or false value. And secondly, the loop is executed until the condition evaluates to false. So it will run forever until this condition is not satisfied. Then let's take a look at an example of nested while loops. So consider a doctor's office schedule. Each appointment is 30 minutes long, and the program prints time in hours and minutes in the range between 8 a.m. and 10 a.m. Let's see. Okay, so the code is like this. The starting value of hour is 8, because you will start from 8 a.m. and minute is equal to 0. So from 8:00 a.m. while hour is less than or equal to 9, and while minute is less than or equal to 59, print hour colon minute. And then we add 30 to the current minute. And because each appointment is 30 minutes long, so the step has to be 30. And then this is the inner loop. It's about minutes. And the outer loop is about hours. Hour is equal to hour plus 1 until 9. And minute will be tuned back to 0 because in each hour, minute is a cycle from 0 to 59. Let's see how it works. So this is an example of a nested while loop. Next topic, fine-tuning your loops with break and continue. The break statement breaks out of the loop entirely, completely. No matter how many layers your loops have, it will break all the loops. And then continue. So this statement skips the remainder of the current loop and goes to the next iteration. So this one will only break the current loop and then continue to the next iteration. And this can be used in both for and while loops. Let's see some examples. So first, print a string of even numbers. For n in range 10, if n modulus 2 is not equal to 0, which means the remainder of n divided by 2 is not equal to 0, then continue. We know that if n is even, then n divided by 2, the remainder is 0, right? So if it's not equal to 0, the number must be odd. If it's odd, continue. Continue means skip the rest of the statements and go to the next iteration. So we'll go to the next number of n in the list. And if it's an even number, then this is not true. So we'll not continue. So the number will be printed. So let's see how it works. So this is how continue works. Now let's take a look at an example of break. So S is a sentence. Merry Christmas and Happy New Year. Let's create a for loop for letter in S. So letter is a looping variable. In S, if letter equals and, break and print letter and equal. Basically, this code tells you that please print everything, all the letters until this and character. And so let's see how it works. Okay, so it works pretty well. Alright, that's all for today's video. In the next video, we'll talk about how to define functions using what we have learned so far. Thanks for watching. See you next time. Hi, today is December 26, 2024. In this video, we will talk about Python functions. To make our Python code more readable and reusable, we can create functions. In this video, we will talk about two ways of creating functions. First, the def statement. We can use it to create any type of functions. And secondly, the lambda statement. This one is useful for creating short, anonymous functions. Before we talk about defining our own functions, let's see how to use functions in general. So functions are groups of code that have a name and can be called using parentheses. We have seen many functions so far already. For example, the print function. Print is the function name, and good morning in this example is the argument. In addition to arguments, there are keywords arguments that are specified by names. So let's take a look at one example. Still, the print function. We can print 1, 2, 3, and then add a keyword argument, SEP, separator. Separator equals hyphen. Let's run this. We use the hyphen to connect the three numbers. Another example is this one. We have seen this before, the AND argument. This is also a keyword argument. By using this argument, we can put the numbers in one line. So when non-keyword arguments are used together with keyword arguments, the keyword arguments must come at the end. Just pay attention to this. So in these two examples, it's very obvious. So these three are non-keyword arguments, and the last one is a keyword argument. We have to put the keyword argument at the end of the argument list. Then let's talk about how to define functions. First, defining functions using the DEF function. We also have seen examples previously. So let's create a function to list n Fibonacci numbers starting from 0 and 1. Whenever we create a function, we start with the DEF keyword and then give a name to the function. We can just call it Fibonacci. And then parentheses. In the parentheses, list all the arguments that are needed for your function. In this function, we only need one argument, which is the number of Fibonacci numbers. L is an empty list. Then we specify the starting values of the Fibonacci sequence, 0 and 1. And then we use a while loop to repeatedly fill the list. The condition is the length of L is less than n. Okay, so let's see how it works. Then suppose we want to list 12 Fibonacci numbers starting from 0 and 1. We can call the function immediately. Okay. You see, this is the result. We only need one argument, which is the length of the sequence, okay, starting from 0 and 1. And functions can return multiple values at the same time. We just need to put them in a tuple format. Namely, we need to separate them by commas. For example, suppose we want to return the real part, the imaginary part, and the conjugate of a complex number. We can create a function like this. So the function name is called real, imagine, and conjugate. And there is only one argument, which is the value. And then we return three things: the real part, the imaginary part, and the conjugate. Okay. So apparently for complex numbers, these three are valid methods associated with complex numbers. So real will call the real part, and imag will extract the imaginary part, and conjugate, this method will calculate the conjugate of a complex number. So let's define this, and then let's apply the function to a complex number 3 plus 4j and see what happens. So 3 is the real part, 4 is the imaginary part, and 3 minus 4j is the conjugate of this complex number. So just for your knowledge, in Python, complex numbers are represented as x plus yj. So it must be in this format, something plus something j, not I. Okay, so x is the real part, y is the imaginary part, and j represents the imaginary unit, which is square root of -1. Next example. And suppose we want to calculate the length and the mean of a vector of values. We can do the following. First, import the NumPy package, and then define the function. We give it a name, and there is only one argument. We call it vect, which means vector, and we will return the length of it and the mean of the vector. Notice that we called the NumPy's mean function. Right? And then if we apply the function to a list of numbers, we get the correct result. The length is 5, right? And the mean of this vector is 3. So the point is, it's possible to return multiple values. You just need to separate them by commas. Sometimes when we define functions, There are certain argument values that we want the function to use most of the time, but we also want to give some flexibility to the users of the function. In this case, we can use default values for arguments. For example, in the Fibonacci function we created before, instead of starting from 0 and 1 always, we can let the user define the first two values in the sequence. In this case, in addition to the number of numbers in the sequence, we can add two more arguments, A and B. And so these two are the starting values of the sequence. And we also give them default values, 0 and 1, which means if the user does not specify the starting values, then A and B will be assumed to be 0 and 1. But if they want the sequence to start with different values, they can do so easily. So let's see how it works. If we don't specify the values of A and B, the result of the function will be identical as before. So if we run it, so the function can still be called in this way because A and B have default values. You don't have to specify them. However, apparently n has no default values, so you have to specify the number of numbers in the sequence. If we want to have a sequence starting from 1 and 3 instead, we can call the function in this way. A is 1, B is 3, so still 12 numbers. So let's run this. Then we get a Fibonacci sequence starting from 1 and 3. And if we specify the arguments by names, then we can change the orders of them. So for example, if we use argument names for all of the arguments, then we can put them in different orders. Originally, we have N, A, and B, but if we specify them using their names, we can change their ordering. Lastly, let's see how to define anonymous functions using lambda. So the lambda statement is a way to define short one-off functions. It looks something like this. Add equals lambda xy colon x plus y, and then we can call the function. See how it works. So 10 plus negative 10, of course, is equal to 0. So this is roughly speaking equivalent to the function defined using the add function like this. So the name of the function is add, and we can just define a simple function like this. Is equivalent to this. That's all for this video, and this is the last video in the Python for beginners in data science. And in the near future, I will create a series of videos about data visualization using Python packages. Alright, thanks for watching. See you next time.